Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exam, that is BYJU'S exam prep. So guys, today in this session we are going to discuss one more supervised machine learning algorithm, that is naive Bayes classifier algorithm. So basically it's a classification algorithm, right? But it uses the Bayes conditional probability. So we'll try to understand that what is actually the Bayes conditional probability and how it can be used to classify the data set into a given class. Okay, so this is brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. Hello Crazy. Okay, so this is my Telegram group. If you guys have any doubt related to GATE exam, whether it is CS paper or DA paper, then you can ask your doubt at this particular channel and I'll be happy to answer. Okay guys, so these are two general announcement. On 15th of October, BYJU'S exam prep is going to conduct a national scholarship test. Do participate in this test, and if you perform good, then you may avail up to 90% off on all our programs. And apart from that, Abhinav Negi sir is going to conduct a workshop on 11th of October at 7:30 p.m. In that particular workshop, sir is going to discuss whether the remaining time is sufficient to cover the syllabus or complete the syllabus effectively or not. So if you guys have any doubt related to covering the syllabus, then this workshop is for you. Now, both the sessions will be conducted on the BYJU'S exam prep live app. You simply need to download the app and you just need to register using your mobile number. It's absolutely free. Now, to download the application, you can use the link available in the description. So link is available in the description. You can use that link. And apart from that, please start participating in the test series. This is just a template of BYJU'S exam prep test series. You can also choose BYJU'S exam prep for appearing in the test series. Okay guys, good evening Panto. So let's start the discussion. New Bayes classifier. Hi, good evening. What about future class of machine learning? Panto, they will be scheduled as and when we'll need it. So please cover this. Now the next session will be related to the questions of this particular algorithm, that what type of questions can be asked from this machine learning algorithm. So let us first cover some concept, then question, then concept, then question. In that manner we will proceed. Okay. So what is a naive Bayes classifier algorithm? So it's basically a classifier algorithm which works on the probability concept. Right? Now, the idea is it uses the Bayes theorem with a naive assumption on independence between features. Now, sir, what is this? What this terminology is? We don't understand it, right? So let's try to understand this. What's the logic? Please try to understand that we are trying to classify our data into a given set. So please try to understand that there are some independent variables, that is your features, right? So let's assume up to n independent variables. These are nothing but the features based on which you will decide that the data item will belong to which particular class, and this y is your output. So you can think of them as input and this y is your output. So please try to understand. What is the assumption? What is this naive assumption of independence between the features? We are assuming that these features are independent of each other. These features are independent of each other. Please try to understand. Let's consider a simple example, that if I want to classify something as an apple, then generally the apple should be of red color. So we may have one feature as color. Getting the idea? We may have another feature as a shape. So let's assume the shape is spherical, right? And you can have one more feature. Let's assume that it is taste, that the taste is sweet, right? So that's the idea. If these three things are satisfied, then we will classify a fruit as apple. Let's try to understand that we are deciding that if the color is red, shape is spherical and taste is sweet, then we are classifying it as an apple. Now the idea is that there is no dependence between these three different features. I mean, if the color is red, then it has nothing to do with the shape. Getting the idea? So there is no dependence between this independent variables or no dependence between this features. But your output variable depends on each one of this feature. Your output variable is directly dependent on each one of this feature, and equal importance is given to each feature. Equal importance is given to each feature. It may not, I mean, it's not so that if it is red and sweet and all of a sudden it becomes spherical, all of a sudden it becomes square, and you are saying that okay, it's too red and too sweet, so it may still be apple. No, it will not happen, right? So equal importance is given to each one of these features. So your output variable is directly dependent. So there is a dependence on these features on the output class, but these features are independent of each other. These features are independent of each other. Clear? The definition. This definition is clear? Understand? Definition is clear so that we can proceed, because that's the first thing, because it is very important. It is very important. The rules of probability which are defined for the dependent events and independent events will be required to understand the concept of naive-Bayes classifier. So these are independent. That's what I'm saying. Right? And this, why? Dependent on each feature. Clear? Now let's try to understand some definitions. So there is independence, there is dependence. So please try to understand independent events. You all know this basic concept of probability, therefore I will not take too much amount of time. So please try to understand, if I toss a coin, then the probability of head or tail, the probability of head is 1 by 2 and probability of tail is 1 by 2. Now my question is, if I toss two coins, if the outcome on the first, coin is head, then what will be the probability of outcome being tail on the second coin? If the probability on the first coin is head, then what is the probability of outcome at the second coin is tail? So please try to understand, each one of these coins are independent, so the probability of head and tail on the first coin will be different, probability on the second coin will be different. Just like if I throw a dice, then what is the probability that the outcome will be 3? If I throw a dice, then what is the probability that the outcome will be 3? So the probability is that there is only one favorable event, that is the outcome is 3. Apart from that, the total number of outcomes possible are 6. 1, 2, 3, 4, 5, 6. Now you have thrown it. Next time, if you throw this dice again, then what will be the probability of 3? Sir, probability of 3 will again be 1 by 6. Now, if I again throw this dice and I ask you what will be the probability of 2, then probability of 2 will be 1 by 6. It means the probability of an event does not depend upon the events which have occurred in the past. So only this channel will the live classes will go for ECE. Yes, obviously ECE classes are already all the same channel. Got the idea? So these are the independent events. Please try to understand. Please. Let's assume that A and B are two independent events. Please, let A and B are two independent events. Then the things which you need to understand are that let A and B are two independent events. And if I ask you that what will be the probability of A given B has occurred, what does it represent, sir? It represents probability of A given event B has already occurred. Can you please provide me the answer that what will be the probability of A given B? Give me the answer. If you know the concept, then give me the answer so that I'll understand that in how much depth I need to go, right? So please try to understand probability of A given B. If A and B are independent, then does the probability of A depends upon this previous event B that has already occurred? Independent events means what? The probability of A does not depend on that event B, whether B has occurred or not occurred. It is not important. The probability of A given B will be same as probability of A any day. Whether B happens or not, probability of A is independent of event B. Yes or no? Yes or no? Do you understand this logic? No. Fanto, please try to understand. What am I saying? Probability of A and B. Probability of A given B. So I am saying A and B are independent. I am saying A and B are independent. So the logic is, if A and B are independent and I am asking that what will be the probability of A given the B has occurred. So does the probability of A depends upon the occurrence or not non-occurrence of B? Please tell me. Fanto, please tell me. Does it depend on that? No, sir. So the probability of event A to occur will still remain same whether B has occurred or not. Sir, other than GATE, what other exams my third year BTech student can apply? Venkat, precisely none. For every other exam, they will want you to be in the final semester. No? Come on. Let's try to understand. Independent events, right? So just the same example. Let's assume if I throw the dice twice, if I throw the dice twice, in the first throw, if 2 was the outcome, in the first throw, if 2 was the outcome, then the second throw, what is the probability that 3 will be the outcome? So I'm asking that what will be the probability of 3 given 2 has already appeared in the first throw? Want to tell me? Now, these are two independent events. When the first time you are throwing the dice, the outcome was 2, that's okay. But the next time when you are throwing the dice, then the probability of 3 to appear as an outcome does not depend on this previous output. Yes or no? So is it not same as probability of an 3 to occur on a dice? It is same as 1 by 6. Are you getting the idea? So I understand that your formula is also right, but I'm just trying to give you an intuition that if you are saying that A and B are independent events, then whether something is given or not given, it will not be important. Now, the independent event has occurred before that particular event A or not, it is not important. The probability of A given B will be exactly same as probability of A. Clear? So that's the logic. So these are the independent events. Now please try to understand. What is the probability of A and B? What is the probability of A and B if A and B are independent events? What is the probability of A and B if A and B are independent events? If A and B are independent events, then A will occur with its own probability, that is probability of A, and then probability of B. So if I ask you that if I throw the dice twice, then what is the probability that in the first throw 2 will appear and in the second throw 3 will appear? So in the first throw 2 will appear with the probability 1 by 6, and in the second throw 3 will appear with the probability 1 by 6. So it is nothing but the probability of 2 to probability of 2. This is nothing but the probability of 3. So probability of A and B will be same as probability of A into B. Clear? So this is a very important thing. If the events are independent, then the probability of A and B will be this. I hope you understand the independent events now. That if the outcome of an event does not depend on the previous outcome or the previous event, if the outcome of an event does not depend on the previous event, then those two events are independent. Clear? Now let's try to understand the dependent event. Let's try to understand the concept of dependent event. Okay. Simple concept, simple thing which you have seen all your childhood. One is that there are, let's assume that there are 3 yellow balls and let's assume that there are 4 red color balls. Now, what is the probability that if you draw a ball from this bag, then what is the probability that the ball will be of red color? What is the probability that ball will be of red color? We'll understand a very important formula. Just like I told you this, I am going to define a formula which is very important, the concept of Bayes theorem. You generally try to mug the formula of Bayes theorem, but you don't actually need to mug it. So no. So what will be the probability in this particular case? Sir, the probability that the ball drawn is of red color will be, there are 4 balls of red color, therefore the favorable events are 4, but the total number of ways in which you can draw one ball out of this bag is 7, therefore 4 by 7, right? Now, if I ask you, if the first ball is red, then what is the probability that second ball is of yellow color? What is the probability that second ball is of yellow color? Please try to understand. We are saying that you have already drawn one ball which is of red color. You are not putting it again into the bag. So the idea is that what will be the probability that the ball will be of yellow color given you have already drawn a red color ball? What is the probability that the ball will be of yellow color if you have drawn a red color ball? So please try to understand that the probability of the ball being yellow given the previous ball of red color will be, what will be the probability? Sir, there are 3 yellow color balls, therefore the favorable events are 3, but after drawing this one red color ball, the overall manner in which the event can take place is 6, so 3 by 6. Please try to understand what is the probability of the color is Y if no other ball is drawn from the bag. What will be the probability of ball being yellow if no other ball is drawn from the bag? What is the probability that ball will be yellow if no other ball is drawn from the bag? Sir, if no other ball is drawn from the bag, then probability will be 3 by 7, 3 yellow color balls, and the overall way in which the event can take place is 7. So do you realize that probability of Y, the probability of Y is different from the probability of Y given the first ball is red? Yes or no? Probability of a ball being yellow is different from the probability of ball being yellow given the previous ball is red. Realizing the effect? So, in case of independent event, the probability of probability that an event will occur will not change because of the occurrence of another independent events. But if the events are dependent, then the probability of new event or probability of the current event will depend on the occurrence of the past event, or will eventually depend on the past events, that what has already happened. Now my question is, very important thing, and if you understand this particular concept, you will get the concept of Bayes theorem. You will get the concept of Bayes theorem. I've just explained this concept. This all you know, right? So please try to understand. If I ask you, just in the previous case, I asked you that what is the probability of A and B? What is the probability of A and B? This time, if I ask you the formula, that in case if A and B are dependent events, if A and B are dependent events, then what is the probability that event A and B both will occur? What is the probability that event A and B both will occur? So please, the logic is quite simple. We want that the event A should also occur and event B should also occur. We simply want one thing, that event A should occur as well as event B should occur. Now, first of all, let's assume that event A will occur. So initially, when no other event took place, then what will be the probability that event A will occur? If no other event took place before the event A, then what is the probability that event A will occur? Sir, if nothing has happened in the past, then the probability that event A will occur will be same as probability of A, just like this, that what is the probability that the ball will be of yellow color? Will be simple, same as probability of ball being yellow color, right? But please try to understand. If we are saying that what is the probability of A and B, then either event A will happen first and then B will happen, or event B will happen first and then event A will happen. Yes or no? Two concepts. Either event A will happen first and then event B will happen, or first event B will happen and then event A will happen. Yes? So please try to understand. If we are saying that probability of A and B, and let's assume that the first event that takes place is event A. First event that is taking place is event A. So if the event A has already been taken place, then what is the probability that event B will happen? If event A already took place, then what is the probability that event B will occur? Tell me. If event A has already occurred, then what is the probability that event B will occur? Simple concept, just try to remember what I told you. A and B are dependent events. A and B are dependent events. So if you are asking that what is the probability of A and B, then first let's say that the first event that occur is event A. So with what probability event A will occur? Sir, event A will occur with probability PA. And if event A has occurred, then what is the probability that event B will occur? Sir, if event A has already occurred, then the probability that event B will occur is the probability of B given A. Will be probability of B given A. Yes or no? Yes or no? Now please, I ask you, if I ask you that what is the probability that first ball is yellow and second ball is red. Please tell me, what is the probability that first ball is yellow? Yeah, Fantu, I know. What is the probability that first ball is yellow and the second ball is red? Sir. Sir, we actually want, the order is not important. The order is not important. The only thing that is required is that event A should occur as well as event B should occur. That means the ball should be yellow and red. The ball should be yellow and red. So what is the probability that first ball is yellow? So the probability that the first ball is yellow is 3 by 7, and the probability that the second ball is red. What is the probability that the second ball is red? So the probability that the second ball is red is 4 by 6, because for red color ball there will be only 6 possible ways in which the event can occur. So this is the value. So what is this value? So this is actually 12 by 42, whatever. Sir, what is the probability that the first ball is red and second ball is yellow? What is the probability that first ball is red and second ball is yellow? Sir, the probability that the first ball is red will be what? So there are 4 red balls out of 7, so 4 by 7. Now, what is the probability that the second ball is yellow? Now, if you have already drawn one red color ball, then the number of possible ways will be 6, and the yellow color balls are 3, 3, 3, 3, 3, 3. Yellow color balls are 3. So it will be 3 by 6. So what is this value? So this value is also 12 by 42. Do you realize by looking at this, that probability of A and B is actually same as the probability of B and A. So if A and B are the two events which you want to occur, then the probability of A and B will be exactly same as probability of B and A. Clear? Clear? Is this statement clear? That probability, what will be probability of A and B? Probability of A and B will be, let's assume that the first event A occurs, then the probability that event A occur, and the probability that B will occur if event A has already occurred will be probability of B given A. Clear? So this is the idea. Probability of A and B will be equals to probability of B and A. Now comes the Bayes theorem. Please try to understand. What do we say? If A and B are dependent events, this is just the derivation of the Bayes theorem. If A and B are dependent events, then probability of event A and B will be same as the probability of event B and A. Now please tell me what will be the formula for probability of A and B. Let's assume that first event A takes place, therefore it will be probability of A multiplied by probability of A, and if A has occurred, then what is the probability that B will also occur? It will be probability of B given A. Probability of B given A, yes or no? Now, what will be the probability of B and A? Let's assume that the first event that takes place is event B. So, if the first event is B, then what is the probability that event B takes place? Sir, if nothing else has occurred in the past, then probability of event B to occur will be simple, probability of B. And if the event B has already occurred, then what is the probability that A will occur? So if the event B has already occurred, then the probability that A will occur will be same as probability of A given B has occurred. Yes or no? Do you realize this? So if I just try to solve in this particular term, that what is the probability of A given B? If I try to solve this, that what is the probability of A given B will be same as probability of B given A. Please look at this. I am just changing the order. Probability of B given A multiplied by probability of A divided by probability of B. probability of B. This is your conditional probability, that is probability of A conditional B has occurred, and this is known as Bayes theorem. Is there something which you need to remember in this formula? Is there anything which you need to remember if you understand the concept of simple independent and dependent events? Is there anything related to that? Is there anything which you need to remember in this particular formula? Ghotala. What ghotala? No ghotala. What ghotala? What ghotala? What is this? Is it some kind of joke, or is there any doubt in this concept? So probability of A given B will be same as probability of B given A multiplied by probability of A divided by probability of B. Please try to understand the next thing. So this is the Bayes theorem. So what did we say? Sir, in the neo-Bayes classifier, we'll assume that the features are independent. We are assuming that the features are independent, and we are also assuming that the output is dependent on each one of this feature. And we are also assuming that output is dependent on each of this feature. Clear? So that's the basic assumption which you need to understand, right? Okay, so let's try to understand the neo-Bayes classifier now. If you have understood the concept of dependent event, independent event, and Bayes theorem. Come on, sir. What is neo-Bayes classifier? Let's assume. So let's again think in the same format. Let's assume that this x1, x2, x3 are nothing. x1, x2, xn are your features, and this y is your output. Y is your output. So in the data set, sir, DMJT का combinatorics वाला part complete करें कैसे plan करें? सनी दास, soon I'll start that, don't worry. I mean, हाँ, ये हो सकता है कि आप लोगों को ये लग रहा हो that sir we are getting late, so that I understand, please, right? So please try to understand that in any given data set, what will you have? You will have the values of this x1, x2, x3. So values of x1, x2, x3 up to xn will be given. Values of x1, x2, x3 up to xn will be given, and they will ask that what is the probability of y? What is the probability of y? And we are actually saying it's a classification problem. What type of problem is this? Sir, this is a classification problem. So you can say that the output can either be yes. Let's assume that there are two classes. Output will either be yes or output will either be no with respect to this input independent variable. With respect to this input independent variable, the value of y may be yes, value of y may be no. Now, if you want to check that what will be the probability of y, please, we have just understood the formula. Sir, आप मुझे अपना discrete maths lecture provide करा दीजिए, आपका subject wise नहीं मिल रहा है, please. बेटा मेरे खुद के पास रिकॉर्डेड फॉर्मेट नहीं है, मैंने कर दिया जहां करना था, इट इज नो लॉन्गर अवेलेबल विथ मी, सॉरी. देखो ऐसा नहीं है कि मैं देना नहीं चाहता, बट द ओनली थिंग इज दैट आई डोंट हैव इट, ऑनेस्टली आई डोंट हैव इट. प्लीज डोंट थिंक, अदरवाइज देयर इज नो प्रॉब्लम इन शेयरिंग इट. Okay, so please try to understand the neo-Bayes classifier. What we are trying to derive here is that what will be the probability of y, what will be the let me use a small letter, what will be the probability of y given x, what will be the probability of y given x, where x is what, where x is nothing but all these values x1, x2, x3 up to xn. So what does it mean? What does this equation try to say? That what will be the probability of y, whatever, whether it is yes or no. We'll see whether we are calculating for yes or no. So what will be the probability of y given the value of x. So what will be given in the problem? Sir, we will have the values of x1, x2, x3 up to xn. We will have the values of x1, x2, x3 up to xn, and based on that we will try to determine that to which particular class this data will belong to, or it will be classified into which particular class. It will be classified into which particular class. So if we are trying to define that probability of y given x, so I can define it like this. Please try to understand. We have just derived a formula for Bayes theorem that the probability of y given x will be nothing. Probability of y given x will be nothing, but the probability of x given y, probability of x given y into probability of y, probability of x given y into probability of y divided by probability of x. Yes or no? Sorry, this letter small and yes or no? Please tell me. So this is like discrete distribution. Yes. So please try to understand. Yeah, it will be discrete distribution. So please try to understand. How can I write probability of x? So we are actually trying to calculating that what will be the probability. What will be the probability that x1 will occur, x2 will occur, x3 will occur, and up to xn will occur given y. Given y. Multiply by py. Please try to understand. I have given you a very important piece of information which will be required here. Now what is the probability of x? So it means what is the probability that x1 will occur? X means x is all this thing. So probability of x1, x2, x3 up to xn. Getting the idea? So what will be this probability? Please try to understand. We are saying that y actually depends on x1, x2, x3 up to xn. Y actually depends on x1, x2, x3 up to xn. But with what probability x1 can occur, with what probability x2 can occur, they are independent. Yes or no? They are independent. The probability with which x1, x2, x3 up to xn can occur, they are independent. So if we are saying with x1 and x2 and x3 and x3 and x4 up to xn given y, will it not be same as the probability? Please try to understand, because probability. So you can actually, where is it? So probability, you can also write it as probability of a comma b. You can also write it as probability of a comma b will be probability of a multiplied by probability of b. These are the same denotation. Here it will not be a good approach to write and everywhere, right? So this is the same thing. So it is probability of x1 and x2 and x3 up to xn given y. So what is the probability of x1, x2, x3, x4 up to xn? Sir, they are independent. They are not dependent on each other. They are only dependent on what? They are only dependent on what? That y. They are only dependent on this value y. Yes or no? Because apart from that, x1, x2, x3 up to xn are independent. Getting the idea? Getting the idea? So can I write it like this, that x1 only depends on y, x2 only depends on y. They do not depend on each other. So can I write it like probability of x1 given y, and therefore this will be multiplication because independent. So if they are independent, then probability of x1 comma x2 can be written as probability of x1 multiplied by probability of x2. So probability of x1 given y multiplied by probability of x2 given y, and so on up to probability of xn given y, and obviously this probability of y is there. This probability of y is there, and it will get divided by what? So it will get divided by probability of, now what is this probability of x1, x2, x3? So they are all independent. So you can simply write probability of x1 multiply by probability of x2 multiply by up to probability of xn. Up to probability of xn. What are you saying, Rolex today? Got the idea? Please try to understand this. Please try to understand this. Please. This is just the beginning. But we are just saying that the probability of y given x. The x may be given as anything, and the probability of y can be any class. Probability of y can be any class, and x can be anything. Getting the idea? So we'll understand with an example that how this particular solution, particular thing can be solved. But as of now, please try to understand this x1, x2, x3 up to xn are fixed in the manner in which they can appear. So probability of x1, probability of x2, probability of x3 up to probability of xn, they are going to remain same for a given input set. They are going to remain same. Sir, India won the first match against Australia. Okay, congratulations. Congratulations. But don't mind. It's not that I'm not a supporter of Indian cricket team. I'm actually not at all into the cricket. So that's a different thing. Then don't think that, sir, you are not supporting India. I definitely support India. But something which I don't understand is cricket. Right? So the reason is that I have not watched so many cricket matches since my childhood. So I was unable to develop that interest. So that's the only reason, nothing else. Right? So you eventually develop your interest if you keep doing that thing. But I didn't do that, and therefore I'm sorry. Okay. Anyway, let's begin. This is the probability. So do you realize that this denominator is actually a constant? Do you realize that this denominator is actually a constant? Yes or no? Now, another thing which you need to understand is that we are saying that the probability of y, but probability of y being what? We are saying that the probability of y being what? So the probability of y being yes or probability of y being no? Yes or no? Probability of y being yes or probability of y being no is what we are trying to define. So please try to understand. Just keep this particular thing in the mind. Keep this particular thing in your mind. And please see. So that what is the probability of y being yes? What is the probability of y being yes given x? What will be a probability of y being yes given yes? So please try to understand. Given x. Please try to understand. X is same, x1, x2, x3. This y will only get changed by y equals to s, y equals to x. So can I write it that it will be same as probability of x1 given y equals to s multiply by probability of x2 given y equals to s, and so on up to probability of xn given. So what is given is that the class is yes. What is given is that the class is yes. And obviously the last thing is probability of y. So probability of y is simply nothing but probability of y being yes. Probability of y being yes, because we are looking with respect to yes. We are checking with respect to yes, divided by. Sir, this numerator actually depends on y. This numerator actually depends on y. The denominator will remain probability of x1 and probability of x2 and probability of x3 up to probability of xn. So basically this denominator is not going to change with yes or no. This denominator is not going to change with yes or no, because it is not with respect to yes or no, it's the overall probability of x1, overall probability of x2, etc. So similarly, if I define that, what will be the probability that y belongs to class no? What is the probability that y belongs to class no? So what will be the probability that y equals to no? So what will be the come on. What will be the probability that y belongs to no given x? Sir, this will also be same, that we are just checking that what is x with respect to y equals to probability of x1 given y equals to no multiply by probability of x2 given y equals to no, and so on up to probability of xn given y equals to no. And obviously there is a multiplication term. I don't know whether you are able to see it or not, इसलिए मैं इसको थोड़ा सा ऊपर ले जा रहा हूँ. Probability of y equals to no divide by same thing, divide by probability of x1 into probability of x2 and so on probability of xn. And please remember one thing, that this thing is not going to vary with y equals to yes or y equals to no. This denominator is not going to vary with y equals to x or y equals to no. So can I simply say one thing, because this thing is not going to change with the value of y, because this thing is not going to change with the value of y, can I write it like this, that the probability of y, whatever y is x, yes or no, probability of y with respect to x will be proportional to, because this is just a fixed value. For yes also this denominator will remain same. For no also this denominator will remain same. Will be same as probability of x1 given y, probability of x2 given y, and so on up to probability of xn given y multiply by probability of y. Can I write it like this? Can I write it in the form of proportionality? Yes, sir. Because whether it is y or yes, y equals to yes or no, whether y equals to yes or no, your denominator is not going to change. Therefore, it can be treated as a constant term, which is the proportionality constant. Can I think of it like that? Can I think of it like that? So probability of yes will eventually be larger or smaller with the same factor with respect to probability of no, because this denominator term is exactly same. Hello, please guys, say something. I don't know what you guys are waiting for. No sir, हम कुछ नहीं बोलेंगे. चलो मैं ही बोलता हूँ. Consider an example. It's a simplest example. I am not taking multiple independent variables. I am not taking multiple independent variables. Let me just explain that how this type of questions can be solved. How this type of questions can be solved. Let us just try to understand that particular thing. So, do you realize that there are different types of things? There are outlook, that is what is the weather. Basically, we are talking about weather. That what type of weather is this? Sir, the weather may be rainy, weather may be sunny, and weather may be just cloudy, right? Overcast. So these are the three different types of outlooks are available. So please try to understand. If I just try to get the information that in what particular weather the match is played or not. So please try to understand. Please try to understand. If you are not getting it, then please try to understand that this is your x1. That is your independent variable, and this play is y. That is play. That is match will be played or not. So it can be any type of match. It may be a cricket match. You are just asking about cricket, so it may be a cricket match, golf match, football match, whatever, right? So this is a match will be played or not, right? So let's try to divide this. So first of all, what will you do? You will just try to understand that with respect to particular independent variable, what is the outcome, or how many times the outcome is yes and how many times the outcome is y. That means with respect to a particular independent variable, how many times are different, but how many times the output is from a particular class. How many times the output is from a particular class. So just try to understand that if I say outlook, please, this will be very helpful. A question can be asked from the neo Bayes classifier algorithm, and I believe that, I don't know why I think that a question will be asked from this particular topic. A question will be asked. Somehow I feel so. Right? Now, the outlook may be rainy, it may be sunny, and it may be overcast. Now, when the outlook is rainy, how many times the match is actually played? When the output is rainy, how many times the match is actually played? Sir, rainy, yes. Rainy, yes. Rainy, no. Rainy, no. No. So, how many times the match is played? Sir, if outcome is rainy, क्या कर रहे हो? Right, so if outcome is rainy, the match is played only twice. Now, sir, if outcome is sunny, how many times the match is played? Sir, 1, sunny 1, no sunny, sunny 2, no sunny, sunny 3. Sir, sunny. If outcome is sunny, how many times it is played? Sir, 3 times. right? So if outlook is overcast, then how many times the match is played? 1, 2, overcast, 3, overcast, 4, overcast, 5, right sir? So 5 times the match is played. So overall, how many times the match is actually played? Sir, 5, 3, 8, 2, 10. Sir, 10 times the match was played. How many times the match was not played when the outlook is rainy? So let's try to understand with respect to no. Let's try to understand with respect to rainy, 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 rainy. 1 rainy no, 2 rainy no. Clear? So rainy no will be 2. Sir, how many times the match is not played when forecast is 5? Yeah, I guess I wrote right. So how many times the match is not played when the outlook is sunny? Sunny, sunny, sunny. So sunny 1, sunny 2. Sir, only 2 times it is not played. Sir, how many times the match is not played when the outlook is overcast? So sir, all of them are done, therefore no. So how many times the match is actually not played? How many times the match is actually not played? Tell me. Sir, 4 times. 4 times. Clear? This matrix is easy to obtain. This matrix is easy to obtain. Now please, if I ask you, what will be the, how many total outcomes are there? How many total outcomes are there? Please tell me. How many total outcomes are there? Sir, total outcomes are 14. So what is the probability of yes? Sir, probability of yes which is not dependent on anything. So the probability of yes is, how many times it is yes? Sir, it is yes 10 times. It is yes 10 times. How many total times? How many total number of data items we are having? Sir, 14. So it will be 10 by 14. Sir, what is the probability of no? It is just the simple probability of yes and no, because these are yes and no. So the probability of no. So the match is not played 4 times out of 14 times. The match is not played 4 times out of 14 times. So is it simple to calculate probability of yes and probability of no? Please, 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 please. You will require this probability of yes and no. You will require this probability of yes and no. Therefore, we actually need to calculate it. Yeah, so we should have the probability of yes and no, that how many times out of all the outcomes, how many times the class is actually yes, and out of all the classes, how many times the class is no. Clear? So that's what you will realize. Apart from that, what we need to calculate is, this is very important, that if it is overcast, then what is the probability that match is not played? What is the probability that the match is not played? That's what I'm asking. Please look at this. So let me create a different table so that I'll be able to explain. This is just one particular aspect. What can we do? Okay. So let's try to understand. If I want to calculate something, that if somebody asks me, this is just one variable, so don't worry. Sir, what is the probability? Let's try to understand. If I ask you that what is the probability that match will be played, that is y equals to yes. We are considering this as y. So what is the probability that the value of y will be yes given outlook? Given outlook is actually sunny. What will be the probability of match being played if the outlook is sunny? How will you define it? How will you define it? Sir, probability of A given B will be what? Sir, probability of outlook equals to sunny given y equals to yes. Sir, I am not making it, I am not trying to solve it with respect to multiple variables. Otherwise, if you are saying that outlook equals to sunny, and some other feature is also there, let's assume temperature. So, or let's assume temperature, and we say temperature is hot, cold, moderate. So what is the probability that match will be played? Outlook equals to sunny and temperature equals to hot. So this type of in this type of manner the questions can be asked, but let us just try to understand one simple concept so that you will get familiar with this particular thing. So sir, probability of outlook equals to sunny given y equals to yes and multiply by what? Sir, multiply by probability of yes. Multiply by probability of yes. Divide by, sir, probability that outlook equals to sunny. Now, can you please tell me, based on this particular analysis, can you analyze that what is the probability that outlook is sunny when the match is played? What is the probability that outlook is sunny when the match is played? With what probability the outlook is sunny given match is played? What are you guys doing? Please tell me what is the probability that outlook is sunny given the match was played? Think. Think. Sir, so when we are saying that the probability of sunny given yes, so given yes, so the outlook is sunny 3 times out of 10 times when the class was yes. So out of 10 times when the class is yes, the outlook is sunny only 3 times. So can I say, please look at this, probability of sunny or probability of outlook equals to sunny given y equals to yes. Probability, please tell me, is it clear to everybody that probability of outlook equals to sunny given yes? I can solve it in a different way also, but please try to understand this thing. Okay, if you are not getting it, sir, outlook equals to sunny given yes. So probability of A given B, are they dependent events? Are they dependent events? Yes sir, outlook and yes. So please try to understand. Can I write it like, write it like that probability of this given. So it is like what? Sir, probability of A and B. How do we write it? Probability of sunny and y equals to yes. Probability of sunny and yes will be what? Probability of yes. Yeah. Probability of yes multiply by probability of sunny given yes. Probability of yes. So if I simply divide it by probability of yes. So if I simply divide it by probability of yes, will this problem be solved? Will this problem be solved? But see, this way it will become complicated. This way it will become complicated. So just think, what is being asked? What is being asked? Sir, what is the probability that the outlook is sunny? So how many times? So with what probability outlook is actually sunny when the condition is yes? Sir, overall, what is the probability of sunny? If I ask you what is the probability of sunny? Hello, probability of sunny. Probability of sunny. Sir, out of all the times, how many times the outlook is sunny? 1, 2, 3, 4, 5. Sir, out of all the times, the outlook is sunny 5 times. So it will become 5 out of total how many? 14. So this is the probability of sunny. Probability of sunny is 5 by 14. Yes or no? Please. Probability of sunny is 5 by 14. Now, but what I'm asking is, what is the probability that outlook is sunny? So this is the probability of outlook being sunny. but not the conditional probability. The probability that outlook equals to sunny given y equals to yes. So when y is yes, how many times sunny is how many times the outlook is sunny? Sir, only 3 times. So this will be nothing but 3 out of 10 times. 3 out of 10 times. Is this okay for everybody? Is this okay, that probability of outlook being sunny? So we know this particular probability, that what is the probability of this? Sir, we also know the probability of yes. We also know the probability of yes. So can we calculate this value? Sir, probability of outlook equals to sunny given y equals to yes. Probability of outlook equals to sunny given y equals to yes is nothing but 3 by 10. Yes. Multiply by. What is the probability of yes? Sir, we know the probability of yes is 10 by 14. How many times the class is yes out of overall classification? Sir, it is 10 by 14. It is 10 by 14. Now the another question is, what is the probability that outlook is sunny? Sir, we have just calculated. The outlook is sunny with probability 5 by 14. The outlook is sunny with the probability 5 by 14. Yes or no? So if I just cancel it out, so 14 will get cancelled out, 10 will get cancelled out, it will come out as 3.3 by 5. So it will be 0.6. So that the probability, so please try to understand, the probability that match will be played if outlook is sunny is 60%. The probability that, so obviously, do you realize that if I am taking care of complete probability, please, here I am saying that in some of the examples you will see that this term will be ignored. This term will be ignored. But here I am taking care of complete probability formula. So this is the actual probability that with what probability the match will be played if outlook is sunny. With what probability match will be played if outlook is sunny. At the same time, so this is the probability that the match will be played if outlook is sunny. If I ask you that what will be the probability not played, what will be the probability that match will not be played given outlook is sunny? So when the outlook is sunny, match may be played, match may not be played. When the output is when the outlook is sunny, match may be played and match may not be played. So with the probability match will be played, with what probability match will not be played. So whatever probability is more, will eventually classify a new input into that particular category. It means if outlook is sunny, and the probability of y equals to yes is more, then we will say that match will be played. If outlook is sunny and the probability of match being played equals to no is more compared to yes, then whenever outlook is sunny, we will classify into that match will not be played. Clear? So that's the idea. So what will be the formula? So it will be probability of outlook equals to sunny given y equals to no. So, but what probability outlook will be sunny when the match is not played? And probability of no divided by probability of outlook equals to sunny. Do you realize? So what is the probability? Let's try to calculate here. So what is the probability that outlook equals to sunny given no? So when the class is no, when the input is classified as no match is played, how many times the outlook was sunny? Sir, 2 times the outlook was sunny. Out of total how many times? Sir, 4. Out of 4 times, only 2 times the outlook was sunny. So this is the total number of cases when the class was no, and this is the total number of cases out of all those classes when the out of all the scenarios when the class was no but the outlook was sunny, right? So it is the probability of outlook. Say what is the probability of outlook equals to sunny given y equals to no, that is match is not played. So out of all the times the match is not played, 50% of time the outlook was sunny. Out of all the times the match was not played, 50% of time the outlook was sunny. Therefore, the probability of outlook being sunny when the match is not played is 50%. 0.5. Clear? So it's nothing but 2 by 4. Let's use it directly. So this will be nothing but 2 by 4. I've just calculated that. 2 by 4. What is the probability of no? Sir, probability of no. Out of 14 times, 4 times the match is not played. Therefore, the probability of no is 4 out of 4 by 14. 4 by 14. Now, what is the probability of outlook being sunny? Oh. What is the probability of outlook equals to sunny? Sir, probability of outlook equals to sunny is 5 by 14. It will remain same. It will remain same. Denominator will remain same. Denominator will remain same. It does not depend on no or it does not depend on yes. Clear, sir? So, what will it be? So, 14 cancelled out. 4 cancelled out. It will be 2 by 5. Sir, what will be 2 by 5? Sir, 2 by 5 is actually 0.4. Do you realize? So, sir, what do you see? Sir, very first thing. Probability of match being not played when the outlook is sunny and the probability that the match being played when the outlook is sunny, the summation should be 1. The summation should be 1. Yes or no? Summation should be 1. So, the first observation is probability of y equals to no given sunny plus probability that y equals to yes given sunny will be equals to 1. Yes, sir. And one thing, sir, whenever a new input is given in which the outlook is sunny, whenever the new input is given when the outlook is sunny, our model will classify that particular data into yes or no. That's my question is. So, do you realize one thing, that the probability of y being yes given sunny is more than the probability of y being no being given sunny. Therefore, if outlook equals to sunny, if output equals to sunny, then we will classify it as y equals to yes. So, are you able to classify it into a class based on the given input? Are you able to classify your input into a class using this particular probability concept? Yes or no? Are you able to classify a given input using this particular concept? Now, the only difference is that I did not want to make it too complicated, but you guys can do one thing. There are multiple examples available. There are multiple examples available with respect to same thing, that is outlook and in some of them there will be more number of features. In some of them there will be more number of features. So you can use those example and let's try to understand. Let me give an example that let's assume let feature equals to outlook is one feature. Another feature I can give you as temperature, and you can actually take a random table. You can eventually choose a random table. So this is another. What else should be there? Outlook, temperature, humidity, these are the let feature equals to this. So if I ask you what is the probability of y, what is the probability of y given, let's look something that outlook in the feature outlook, let's assume there is something like raining. So that's okay. That's already, we have already seen this. Comma. Outlook should be rainy and temperature should be cold and humidity should be low. In the rain you are saying low humidity, it's a different thing, but please try to understand that how will we solve this? Sir, probability of y given this will be probability of this given by. So probability of this given by will be probability of outlook equals to rainy given by multiplied by probability of cold given by probability of low given by, and we know how to calculate these different things. We know how to calculate these different things, and we will be able to solve this particular thing. So I just didn't want to make it complicated, therefore I have taken a simple example. Anyway guys, that will be all for this particular session. I hope you have understood the concept of naive Bayes classifier completely. You are also able to understand the Bayes theorem, that how actually it is derived. You are also able to differentiate between the independent events and the dependent events. You are also able to define the formulas, that what will be the probability of A and B when A and B are dependent events, and when A and B are independent events. So we have seen all the different cases. That will be all for this particular session. Thank you very much for joining the session. If you like the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon so that you will get the notification about such upcoming videos. Thank you very much guys. Good night. Keep learning. Take care.